Let's solve some questions from Locus and Constructions. Now, there'll be either MCQs or construction based questions from these topics. These two MCQs are from 2024 specimen paper and board paper. Now, first MCQ is that the three vertices of a scalene triangle are always equidistant from a fixed point. And then the point is which of the following? Is it the orthocenter, incenter, circumcenter, or centroid of the triangle? So if you remember, if I have any scalene triangle ABC, then they're asking that these three vertices A, B, and C will be always equidistant from one of the centers of the triangle. And if suppose that point is equidistant from the vertices A, B, and C, let's call it O. So that means OA has to be equal to OB and that has to be equal to OC. So therefore, if I take point O as the center, I will be able to draw a circle which passes through all the three vertices of the triangle. So then this point will be the circumcenter of the triangle. So the circumcenter, as we know, is always equidistant from all the three vertices of the triangle. So option C is correct, circumcenter of the triangle. Then the next question is again asking about the circumcenter of a triangle. So circumcenter of a triangle is the point which of the following? So is it at an equal distance from the three sides of the triangle? Is it at an equal distance from three vertices of the triangle? Or is it the point of intersection of the three medians of the triangle? Or is it the point of intersection of the three altitudes of the triangle? So it's related to the previous question. We have already seen that. So circumcenter is equidistant from the three vertices. So option B is correct. Option A, a point which is at equal distance from three sides of the triangle, that is actually the incenter. And point of intersection of three medians is known as centroid. Point of intersection of three altitudes is known as orthocenter. So you need to know about the four centers of a triangle. That is very important. Moving ahead, we have these construction based questions, and it's based on the three locus theorems that you have learned. So first we need to construct a triangle ABC in which BC is 6.5 centimeter, ABC is 60 degree, AB is 5 centimeter. Construct the locus of points at a distance of 3.5 centimeter from A. Let's do it step by step. First, we need to construct the triangle where two side lengths are given AB, BC, and the angle between them, angle ABC, is given as 60 degree. So I can start by drawing. It's always a good practice to draw a rough figure. I have already done that before. So whenever you're starting any new construction question, first draw a rough figure to understand how the figure will look like and how much space you need in your paper. Okay, so then let's look at drawing triangle ABC where BC equal to 6.5 centimeter. I can draw that first. So I'll take my ruler and I'll draw 6.5 centimeter line segment. Okay. Then I have to construct angle ABC, which is angle B equal to 60 degree. I'll take my compass, center at point B with some suitable radius, and I will draw one arc. Then center over here, I'll cut the arc over here, and then I will join these 2 points. Okay. Then I need AB 5 centimeter length. So I can take my scale and measure 5 centimeter. So this is point A, and to complete the triangle I have to join AC. Okay, so first part is done to construct triangle ABC. I will also quickly write down the measurements. So angle B was 60 degree, AB is 5 centimeter. Okay. Then the second part is construct the locus of points at a distance of 3.5 centimeter from A. So point A is located here. I need to construct the locus of points which are always at a distance of 3.5 centimeter from this fixed point A. So this is the first locus theorem which talks about a circle. So the locus will be a circle with center A and radius 3.5 centimeter. So I'll take my scale, take my compass and measure 3.5 centimeter radius on the compass. Then place the center at A and draw a circle. Once I have finished all my construction, I also have to briefly describe what was the locus that I have constructed. Okay, then the next is construct the locus of points equidistant from AC and BC. So according to the locus theorem, if I have AC and BC, the locus of point equidistant from AC and BC will be the angle between these lines, which is angle C. So I have to bisect angle C or construct the bisector of angle C. So I'll take my compass, take some suitable radius and draw an arc cutting AC and BC. Then I will take this point as the center and I'll cut an arc somewhere here. Then center over here, cut the previous arc here. Then I will join point C and this point. So this is part 3 done. Then the last part is mark 2 points X and Y which are at a distance of 3.5 centimeter from A and also equidistant from AC and BC. Measure XY. So part 2, the locus was the circle. All the points on the circle are 3.5 centimeter from point A. And the third part locus was the bisector of angle C, and all the points on this angle bisector are equidistant from AC and BC. So then if I look at the intersection of the circle and the angle bisector, I will have 2 points. So I will label the 2 points as X and this is Y. These 2 points X and Y satisfies the second and the third part at the same time. Then they're asking us to measure XY. So I'll take my scale and I'll measure the length of XY. So here I'm getting close to 5.2 or 5.3. Okay, I can write 5.3. So as I said, I have to write down some brief description of part 2, 3 and 4. Part 2, below the construction you write, locus of point equidistant, at a distance of 3.5 centimeter from A is actually a circle with center A and radius 3.5 centimeter. Then third part, the locus was bisector of angle ACB. And the fourth part, the length of XY was about 5.3 centimeter. Moving ahead to the next question. Construct a triangle ABC with AB equal to 5.5 centimeter, AC equal to 6 centimeter, and angle BAC equal to 105 degree. Hence, construct the locus of points equidistant from BA and BC. Again, there are multiple subparts. We'll start with the construction of triangle ABC. Again, it's better to draw a rough figure. AB and AC length are given, and the angle A, which is angle BAC, is also given as 105 degree. So you can draw any one of the line segments first. So let's say I am taking AC equal to 6 centimeter and I'm drawing this line segment here. AC 6 centimeter. Then angle BAC is 105 degree, which is basically angle A. I'll take my compass, center at point A. I'll draw an arc like this. Now 105 degree will be in between 90 degree and 120 degree. So I'll do this construction. This is 60 degree. This is 120 degree. And if I bisect it, I get 90 degree. So I'll just lightly draw my 90 degree and 120 degree. I'll draw it lightly because those are not the angles which I actually want, but it will help me get 105 degree. So this is 90 degree, as you know, and if I join this, I get 120 degree. So this is 120 degree. If I bisect 90 and 120, the difference is 30 degree. If I bisect 30 degree, I get 15 degree. So 90 plus 15 will give me 105. So to bisect, I already have one arc cutting both the arms. So I'll put my center here, draw an arc here, put my center here, cut this arc here. Then point A along with this point. I'll join these 2 points. So this is my 105 degree angle. And length of AB is 5.5 centimeter. So I'll measure 5.5 centimeter here. So I get this point. So this point I will mark as B. So angle BAC is 105 degree and AB length is 5.5 centimeter. And I will also join BC to complete my triangle. Okay, now I have my triangle ABC ready. Now I have to construct the locus of points equidistant from BA and BC. BA and BC. So according to the locus theorem, I have to bisect angle B. that is going to be the locus of points equidistant from the intersecting lines BA and BC. So for that I need my compass. I will draw an arc to cut BA and BC. Then I'll draw these arcs. And I will join point P with this point here. So bisector of angle B is the locus for part 1. Okay, done. Then construct the locus of points equidistant from B and C. Point B and point C, the locus will be the perpendicular bisector of the line segment BC. So I'll take my compass to draw perpendicular bisector. So center at point C, radius should be more than half the length of BC. Then one arc here, another arc here, then center at point B, cut the previous arc here and here, then join with the scale. Okay, so this perpendicular bisector is the locus for part 2. Then mark the point which satisfies the above two loci as P. Measure and write the length PC. So angle bisector of angle B was this, and the perpendicular bisector of BC is this, and they intersect at this point. So this I have to label as point P. Okay. And then I have to measure the length of PC. So I will also join PC. And then the measurement of PC will be about 4.8 centimeter. Okay, so just below the construction I will describe the locus of first two parts. So the first part, locus was bisector of angle ABC. Second locus was perpendicular bisector of BC, and the length PC is about 4.8 centimeter. So for constructions, you don't need to write any other steps of construction, but just a brief description of the locus, and if they have asked you to measure and write some length, that you need to write. Then let's look at one more question from Locus Constructions. Question is, to construct a semicircle with diameter BC equal to 7 centimeter, locate point A on the circumference of the semicircle such that A is equidistant from B and C. Okay, so let's start with the first step, constructing semicircle with diameter 7 centimeter. So I can draw a line segment of length 7 centimeter first. So this is BC, diameter 7 centimeter. To draw a circle or semicircle, I need to know where is the center and what is the radius. So since BC is the diameter, the center will be at the midpoint. Now instead of locating with my scale, let me quickly draw a perpendicular bisector. That is the recommended procedure to locate midpoint of any line segment. Then this is the center of my semicircle. So I'll take my compass, put the center over here, and the radius will be equal to this length. Now I don't have to draw a full circle. Semi is half the circle. So I will draw my semicircle like this. Okay, done. Now I have to locate point A on the circumference of the semicircle such that A is equidistant from B and C. So B and C are these fixed points. A is going to be equidistant from B and C in a way that A has to be on the perpendicular bisector of the line segment BC, which anyway I have drawn to locate the center of the semicircle, and this perpendicular bisector is intersecting with the semicircle at this point. So this will be point A. Okay, done. Then complete the cyclic quadrilateral ABCD such that D is equidistant from AB and BC. So let me join AB. Okay, I need a point D on the circumference of the semicircle so that it's equidistant from AB and BC. That means it has to be on the bisector of angle B. So I will draw the bisector of angle B. Take my compass, center at B. Cut the two arms. Then from this point and this point, I will draw arcs. They intersect at this point. And I will join this. So then this point is the intersection of the angle bisector and the semicircle. So I will label this as D. So D is equidistant from AB and BC now. Then I have to measure angle ADC and write it down. So join AD and DC. That completes my cyclic quadrilateral anyway. Then you have to take a protractor and measure angle ADC. It's an obtuse angle. Now it will be helpful if I can extend one side just for measurement of the angle. Otherwise there was no need to do that. Okay, so this line is In between 130 and 140, exactly, this is 135. So angle ADC is 135 degree. So I'll just write down the measure below the construction, that angle ADC is equal to 135 degree. So this is complete.